Hi, everyone. Thanks for joining. My name is Gregor Wobbe. I'm head of data architecture with UBS. And if you're curious about how we tackle the data integration challenge and the data management at scale in a large global company, you came to the right talk. Take a step back. The bigger picture. So we at UBS, when you break it down, the essence of what we're doing is we are helping our clients to manage their risk of moving money through time. And how we do this, if you think about it on a spectrum, on one side, it's a trusty checking account or savings account, low risk, low rewards. And on the other side of the spectrum is some sophisticated derivative trading, which usually comes with a higher risk, higher reward. And we created something to manage the spectrum. And we call this a business application. And we managed to create 5,000 of those business applications. Why do I tell you about it? It is a challenge when it comes to the data. So each of those 5,000 business applications are depicted here as a walled garden. It comes with its own budget, its own team, usually its own database, its own language, own structure of the data. So that in itself gives you an idea of the scale. We have roughly 70,000 employees working on those 5,000 business applications. In itself, having 5,000 business applications is, if you just look at one, is not a big problem. They're not all client-facing. They're also helping the back of the house. There are HR applications, IT applications, but the majority is business-facing. And take one application for itself, comes with its own database, its own team. It's actually good for privacy, which comes in handy if you work for a Swiss bank. Privacy laws, having that segregated or compartmentalized is actually a good thing. Where it gets tricky is if you're trying to connect data. And that brings us to the major challenge. As soon as you start integrating, and you see that here, as soon as you start integrating just a few systems, it becomes a challenge. If you dial this up to 5,000, it becomes a major headache. And this brings us to the data management at scale. This is our goal. This is what we want to provide for our 70,000 employees. We want to have a well-curated data layer. We want to make sure that every employee finds the data that they're looking for. Once they find the data, that they understand it, which also is a challenge if you have 5,000 different languages, 5,000 different structures. Once they find and understand the data, I want to make sure that they trust the quality and accuracy and timeliness of it, and then that they're allowed to use it. Do they have the right to use it in the right locale? Do they have the right from a licensing perspective, and all of this with the goal of reuse as much as possible. Also makes a nice acronym. That's the future where we want to bring the organization towards. And you see this, I'm not going into the LLM. I think there are plenty of talks about LLMs on this conference. But one of our major goals once we have that well-described data layer, we want to use it for artificial intelligence. We want to gain some insights from the data. The approach to get there, to even explain 5,000 different applications, is fairly straightforward. It's only 4 steps, and that hasn't changed in the last 10 years. So we want to catalog all our data assets from our 5,000 applications. Then we build a conceptual layer, call it the enterprise data model, and then map the data to the conceptual layer. So that in itself hasn't changed, nothing new here. What changed is, or what we came to realize, because we tried this for the last 10 years, and we have every data catalog in the market in the firm. So we have not just one data catalog, it's depicted here nicely, just one data catalog would be great. We have multiples. Same with a schema. We don't have just one schema. We have multiple places where people just describe data, mostly Excel spreadsheets, unfortunately. And then we have down there 5,000 applications. So that in itself was the challenge. And we sat together and decided, let's do this time around, after 10 years trying, so the second paradigm is this time around, we're not attempting to build a central team doing the data management aspect. We federate out the work in decentralized fashion. So this is the theory. Now, let me go into a bit more technical details. We built something, we call it a data service. That is the smallest unit of work. It's basically a virtual machine that we can fire up. It sits on Kubernetes, we can fire up. And this is what it looks like. It's a Kubernetes virtual machine that comes up and reads data from a source. It reads from our internal schema and translates the data that it reads from the source into JSON LD, linked data. And that was, for us, the big aha moment, because all of a sudden, we got the buy-in from developing community. The engineers were on board. Say, hey, that makes a ton of sense. We just have to basically create a configuration file. That is the mapping in the data service. We can expose our data, but we can keep our source. We can keep our system. And we have roughly 80 systems providing, I'll show you this in a second, also in the next diagram. And we pipe it out. And our pipe that we put this data in is based on Kafka. So we go out to those 80 source systems. They're not all data catalogs. There's a variety of systems, 80 systems involved. And we said to every system, here's your data service. You can fire it up and expose your data for the greater good. Greater good being for the rest of the organization. And pipe it through Kafka. And at the end, everyone who wants to take the data can grab it from the sink. So that's the smallest unit of work. And this is basically our piece of software that we expose to the organization. Every application that wants to expose their data, they take one of those data services and expose it via JSON LD. The JSON LD is then explained in our internal schema, similar to schema.org. It's exactly the same what happens on the internet with structured data. Where this comes in handy, and this now to the graph concept. at the lowest bottom, we have those app registries. Those app registries are systems that contain information about applications. And you can imagine if there is, right now we only have one, but in times of a merger or if another company merges with our company, there is another application registry. This application registry exposes information about a business application. And usually a business application comes with different environments. Those are those blue diamonds. The next level are, so every application in environment runs on infrastructure. That's the next level. And there are other systems providing information about the infrastructure. What are the servers? What is the network connectivity between those servers? What are the ports, network equipment, you name it. Next level, some of those infrastructure items contain databases. Yet other systems providing information, usually we have scanners that scan our data assets, telling us, oh, here's a bucket with data, or here's a relational database, or here's whatever. Some data asset gets usually scanned. The next level down is each data asset has usually a structure. The structure comes yet from other systems. So we integrate all of this by virtue of Kafka pipes and data services. And at the top of the house, there is the business glossary. And to make matters more complicated, we have more than one business glossary. We have every line of business has its own business glossary. So all of this together lives in Kafka. It's connected via JSON LD, and we pipe it out into a graph database. But we also pipe it out into a data lake. So if someone wants to interrogate or analyze data over time, they usually go to the data lake and are exposed to thousands of files, but then they can cobble it together. So that is the data or the graph component that we're using. We're using JSON LD to write it into a graph database. And it's the beauty of it is all pre-connected. We fan out the work to the producing applications, to the developers to connect the data up front. And we're just sitting in the back and waiting for those files to drop and ending up in our graph database for further analysis. All of this together changed the paradigm. We're no longer talking about tools. Thank you. We're no longer talking about tools, we're talking about the capabilities. And I'll just put some of those capabilities here. Again, those are our tenets: finding, understanding, trusting, using, and reusing data. And the different fields are supported by existing ontologies. So namely DCAT, I'm sure some of you have heard of it, is an open W3C standard that we use to describe data sets. And then we use DQV for data quality, Provo for lineage. Those are always our starting points. In closing, some of the lessons learned. I know the first one is focused on value for the business domains. That sounds like an empty phrase. However, what we did, we really sat down with the business and listened to them. And when I say listen, I mean it, we listened to them. And one of the lessons learned, or the things that came up over and over again, was there is a difference between data registration and data governance. That was in news to us. So we separated those out to great success for the business domains. Also, what helped tremendously was doubling down on using open standards. It's much easier to sell someone on an open standard than to something homegrown. Another lesson learned, team topologies. It's mind-boggling how the setup of your team determines the architecture. And we experimented a lot, shoveling around the team to set it up to allow for this very federated model. Initially, we had one big team, and that was reflected in the architecture. Now we split it up into 4 smaller pods, and the architecture is reflecting this, and it pays off because now the solution is easily scalable and can be federated out. The last two, almost together, this is a long game. It took 3 years to get to this point, and it will take another couple of years. It's a long game, and along the way, just to keep budget flowing, you need to create small wins. That brings us to the end of my presentation. Thank you very much.
Thank you very much. One online question. I'll start here. Go ahead.
At what point through your journey did you federate the team from 1 to 4?
About a year in.
How much time would you have saved if it was federated from the beginning?
That is a good question. I'm not sure. We experimented a lot and still experimenting with the ideal setup. Initially, it was monolithic, and it's hard to tell how much time we have saved.
The decision for the 5,000 apps, was that as a result of top-down management saying you should do this, or people kind of recognized, or maybe both?
You mean that how we ended up with 5,000 applications? That's organically grown. There is, whenever there is a new business function or new product, we usually create an application. If it's the right number.
That came into your kind of ecosystem for what you set up that took advantage of your architecture. What was the driving decision maker to get them to onboard with you?
So we haven't onboarded all 5,000. We onboard the metadata of 80 of those 5,000 and are now scanning in the hundreds. We're scanning more and more and onboarding more and more. It's just metadata that we're interested in.
There's an online question. When you were talking about your JSON LD going into a graph database as well as the data lake and other places, Jesse McPhee at University of Toronto says, what tools are used for the implementation of the graph database?
So we're working with our partners. It's RDF and turtle files. So it's a graph database that we use.
The data, is it a snapshot of every day as of like live stream?
It is. So our goal is near real time. We want to have, if there's someone updates data, we would like to see it near real time. That's the reason why we went with Kafka, to allow this streaming capability. I hope that answers the question.
Yeah. Oh.
Yeah.
Why the source application give you and describe you the data in the way that you want it?
We have to distinct. Some of the applications are exposing their data, and they usually don't give the data in the format that we would like. And we coined the term data unions, that we say, here's a structure. If you talk about this topic, here is a structure, and all of you applications that are dealing in this domain, please agree on this structure and transform your data into this structure. So if someone says, I'm dealing with relational database metadata, then we say, here's a structure. Every tool, please transform your data into this.
Why format. It's important for them to do that?
That's a very good question. And also one of our biggest challenges is to convince people or convince solution owners to share their data, because it's extra work that usually is not. It comes with extra work. So it's a lot of sitting down, convincing that ultimately we all benefit if we share this data.
So use cases. So obviously, yeah, search and discover what data we have and stuff like that. But what are you're saying you're working with the business. So what are the business use cases that's helping to drive revenue or mitigating risk or whatever that you can contribute, you can connect to what you've done here?
It goes back to show me the money. I like this question, by the way. It's because I get this question asked quite often. We also goes back to the small wins along the way. And we're targeting usually cost savings. And it's mind-boggling how much you discover once you have the data. Reducing the data footprint is a low-hanging fruit, the easy one. Identifying archive tables in relational databases, mind-boggling how much stuff there is that you can just exploit and say, if you would just delete the archive tables and put it in an archive service, you would save X amount of dollars. So those are the small little wins along the way that helps paying for the overall initiative.
And is there any, on the other side, revenue generation opportunities?
Not at this point. We're probably too early. That's why it's a long game. 3 years in, I could foresee there is revenue generating potential in the future, for sure.
Any idea what that could be?
I'll let you know privately.
What are the biggest challenges with converting to a federated approach?
The biggest challenge is the complexity of a federated. It's much easier to build just monolithic, the whole microservice, Kubernetes, technology-wise is, it's still a challenge.
Just one last question. In terms of sort of aligning with the business, was there any work done in creating like ROI models, like ahead of time? Like this is what we predict we're going to save, or this is what we're going to make, or what degree was that? Or what planning was important in terms of getting the business alignment between technology and business stakeholders?
So just to play back, where's there plans up front to
In terms of getting everyone on board with, we're going to do this, it's going to take a long time and it's going to cost money. Was there any sort of like ROI models in place or projections for what we're going to do?
not so much an ROI model, a projection in a sense of, we tried for 10 years, we tried it the route with, let's buy a tool that will solve everything. Can we do things a little different? And we knew how much we spent in the last 10 years and said, next time around, can we do things a little different? Can we use open source? Can we build this team? So in that sense, there was a bit of a comparison of, do we want to spend what we did the last 10 years? Should we continue this, or should we try to do things a little different?
Because we're at time, so thank you, Gregor. And I told you to have plenty of questions.
What?